Hi, this is Anthony Pagan, and I'm here to present the final project assignment for Data 605. Okay, so the first part of the problem, we wanted to get 10,000 random uniform numbers. For that, we used the runf to generate a random uniform numbers. And as you can see, based on the histogram, the frequencies are close to even and shows a uniform distribution. The second chart was for a random distribution, and for that we used our norm with a mean of n plus 1 divided by 2, and the standard deviation also of n plus 1 divided by 2. So the minimums we on the next section we wanted to calculate the minimums and the probabilities. So the first probability is the minimum probability of random uniform numbers x being greater than the median number of lowercase x, given that x is greater than the first quartile, and that value was 0.5. The second probability is the minimum probability of random uniform number x being greater than median number lowercase x, and the random number y being greater than the first quartile, and that value was 0.6. The third, we wanted to get the minimum probability of random uniform number x being less than the median, and uppercase x greater than the first quartile, and in that case it was also a value of 0.6. Onto the marginal joint section. So we're checking to see if uppercase x is greater than the median of lowercase x times probability of the values of uppercase y is greater than lowercase y. If those values are equal to one versus the other as a multiplication, and whether we get the probability of x's and y's, and see if they were equal. Based on the table, we're seeing that the values are not equal, but the joint and marginal probabilities equate to 1 in the end. When we checked the independence with the Fisher and the Chi test, those two are checking for independence when comparing categorical data. The Fisher test can be used for smaller data sets as less than 10. In our test, the Chi test has a value of 0.24, and the Fisher test has a p-value of 1. So we would say that the Fisher test fits the data as both values are equal, and the Fisher test is equal to 1. Problem 2, we were tasked to open up an account with Kaggle and submit some test data to show whether our predictions are close to what all the values are being submitted. So on the Kaggle, we're start off by selecting the ID, the sale price, the year built, kitchen quality, bedroom above ground, and neighborhood. And we're start off by removing any of the NA values. So the plots on the GG, so we start off with some summary data for all the data points, which include the minimum, maximum, the median, and each of the quartiles. And then we start to use some of the plots. So we start off with the QQ plot. And when comparing the ground living area versus sales price, it shows that it has a positive correlation on the QQ plot. The ground living area versus sales price shows some positive linearity, and the GG plot when the ground living area is below 3,000. And as you move up, you see that there are some disparities. As we move on to the full bath and sales pricing, it shows another positive linearity. When neighborhood and kitchen quality are added, the linear model has a positive correlation. However, when we move down to year built, you can see that the y-axis or the intercept estimate is below, or has a negative intercept. So here we're looking at the sale price compared to neighborhood, and then here we're adding the year built as the category variable, and the linear line goes away because it's below the is a negative number for the y-axis. And when we're adding the kitchen quality, you see the numbers are still positively correlated. When looking at the bedroom above ground versus sales price, the data is bimodal. There's no correlation. Here also, when we're adding the year built, you'll see that the line for regression goes away. So we're going to look at as you see, we have the year built. And here again, the line goes away because it has a negative intercept. On the correlation test, we have Pearson correlation confirming that with an 80% probability, the ground living area is between 0.69 and 0.72. And full bath is between 0.54 and 0.58. And the bedroom above ground is between 0.14 and 0.20. And as you can see on the correlation matrix, the ground living areas in comparison to the sale price is 0.71, and the second highest would be the full bath at 0.56. On the LU composition, we're using the mathlib to multiply the inverse of the correlation test times the original correlation test to get the position matrix, and then we use the upper dot try and lower dot try functions to get the upper and lower. So here we have the inverse of the original values. Then we multiply the original values with the inverse, and we're getting the null values. Then as we multiply the matrices, so when we multiply the correlation by precision matrix, we're getting the inverse of each matrix. Onto the mass function. For the mass function, we're using the ground living area. The histogram shows the data is right skewed. So we use the log 10 to shift the data to the right and towards the center. And then applying the fit distrib estimate, the histogram again shifts to the right again. And when we apply the PDF to the original value, we get data at 0.5 and 0.9 percentile, and it shows that there is not much of a difference between the original value and the ECDF of the log. As we move on to the modeling section, so we begin with the GGPS data, which compares the sale price to all variables, including the year built, kitchen quality, ground living area, full bath, and bedroom above ground. So the ggplot hints that the full bath and the ground living area are highly correlated with the sales price. We begin with a summary of all the variables, and for the most part, all of the variables show that the p-values are below 0.05, except for the kitchen quality, which seems to be 0, has a 0 p-value. And for all of these summary, we're extracting the coefficients, which include the R-square values, adjusted squared values, the sigma, and the F statistics. So the coefficients are providing the y-intercept, the slope, the p-value, which is the probability that the null hypothesis is true, and the t-value, which gives the standard deviation of the estimate coefficients are from 0. So the multiple r-squared and adjusted r-squared value let us know how close our data is to the linear regression model, and the F statistics gives us the relationship between dependent and independent variables, and a large F statistics would mean that there is a strong correlation between dependent and independent variables. So we begin with the first multiple model, which includes the variables, sale price versus everything. So we have the sales price versus neighborhood, year built, kitchen quality, ground living area, full bath, bathroom above ground. And what we're seeing here is that the full bath, everything has a p-value below 0.5, except for the full bath, as you can see, is 0.89. So the next multiple linear model removes the full bath, and as you can see, all of the values are below 0.5, and that would include all the variables here. When comparing the sales price to the bedroom above ground, we're seeing that the values are below 5. However, if you actually do with the full bath by itself, it also has a p-value of actually 5.0. So that explains the full bath as being having a high p-value. And then when you put the full bath with the bathroom above ground, the combined p-value is actually below 0.25. So the first submission to Kaggle was a comparison of the sales price to ground living area, full bath, and bathroom above ground, and the p-value was its lowest at 0.5 and then minus 18, while the F stat value was high, 679. However, the Kaggle score in this case was 0.28. The submission for sales price versus the full bath, as expected, had a high value for the p-value, and the f-stat was 801, and in this case the Kaggle score was again 0.28, but then we added the full bath and neighborhood, and it reduced the p-value to 3.14 minus 14, and the f-stat was 155. Finally, we swapped the full bath with the above ground, and it reduced the p-value to 1.31 with a minus 17, and an f-stat of 164. That brought the Kaggle score down to 0.210. And that's where I left it off. So, and that's the end of my presentation. Thanks for listening.